So welcome to the Hackfest. I will be giving you a very brief introduction to TeraFlow because there are some newcomers to the project. So well, I think it's nice that we have some brief introduction. I will try not to spend so many time because I was discussing yesterday with my colleagues from Telefonica, and they will need a lot of time for presentations. So maybe let's go quickly with this introduction. Essentially, as I said, it's a 101. Let's start with the classical question that we are raising every time we present the TeraFlow, and it's a quite interesting question because do we yet need another SDN controller? I mean, alert of spoiler. I'm borrowing this expression from Ricard, the chair of the leader group. Alert of spoiler, yes, we need another SDN controller. The reason, it's simple in my view. I mean, nowadays we have 5G networks, 5G and beyond. We are pushing for 6G. And the problem that we have is that most of the SDN controllers that are around are kind of, I will say, deaf in terms of number of contributions they are receiving, functionalities they are offering. So yeah, for sure, you can use them for controlling SDN networks. The problem is that these new generation networks are imposing new stringent requirements, and if the SDN controllers are not following the pace, we are in trouble for controlling the networks. With TeraFlow, what we are trying to do is, okay, we have the knowledge on web scale applications, for instance, for managed large scale applications. We have the knowledge on different SDN controllers. Let's try to mix and match things and try to create an SDN controller that is prepared for the next generation. That means to be scalable, to be self-healing, to provide load balancing capacities in the different functionalities, to be smart. I mean, not like a big monolith that if you want to scale, you just need to replicate it a number of times, and then it's a very big piece of software that sometimes it's repeating code that it's not really necessary. What we are doing here is to create an SDN controller that is based on a cloud-native, it's based on microservices, and that runs on top of cloud-native infrastructures. So at the end, we are inheriting the advantages of these cloud-native applications the ones that I told you before. It's these things of scalability, self-healing. You can provide also security for specific components. It's a big set of, a huge set of advantages that you can inherit. The second important point is based on standards. Okay, we are trying to implement this SDN controller following as much as possible standard data models, standard interfaces, standard workflows when possible, etc. So that way, we try to facilitate the adoption of this SDN controller. If you have a lot of things that are proprietary, then yeah, for sure, you can use this SDN controller with proprietary, the networks that follow these proprietary solutions. But then it's more difficult to adopt for other newcomers. So if we are based on standards, this thing facilitates a lot of our life. Third point, well, I was discussing that before. It's about the microservice-based architecture. I will not repeat myself because I was explaining it together with the first point. The first one is about this toolbox. The idea is that TeraFlow should serve as a toolbox to bridge between the research and the standards, and also the industry. So if we can provide a toolbox that can serve also as a kind of a reference implementation for SDN controllers for future and for next generation SDN controllers, then everybody that has a need of an SDN controller can just jump in TeraFlow and make use of the software that we are producing. That's the view. Okay. We provide support for a number of different use cases. Probably most of you at some point used TeraFlow for some different experiments. Maybe you participated in some of these use cases. To cite, well, later I have a slide with a list of interesting demonstrations that we did in the past, so I will not spend a lot of time right now on this. Well, I was discussing about the multi-SDO goals and so on, acceleration, so I will jump to the next. Important point, the telecom infra project. One of the things that we are doing with TeraFlow is that whenever we have to develop new things, we try to hear what do the network operators need, okay? At the end, the network operators are, let's say, the major user of an SDN controller. They are the ones that have big networks that need to be managed, needs to be automated, and so on. If we can provide an SDN controller that is following their needs, we will facilitate a lot the adoption of the SDN principles, mechanisms, and technologies into the networks that the final users can enjoy. Okay, so for this very reason, we try to be as much aligned as possible with the outcomes of the telecom infra project. And last but not least, about licensing. TeraFlow is and will be Apache licensed. That means everybody can jump in, can use the code. You don't need to pay for getting access to the code, for using the code. It's available for you. Okay? Jumping to the next slide. This is a quite funny slide, I will say, because I was editing this slide some days ago, and I started to be in trouble. I have lack of space in this slide because that's very good. The community is growing, and it's growing quite a lot. That means the things we are doing here make sense, and there is a lot of people that really thinks the same. So you see, I mean, in this slide we started with few logos in the members and in the participant sections. This part of your logo here was quite big. Now we are reducing. That's good. That means community is growing. So thank you for all of you for being part of the community, and let's keep pushing for growing the community. Another interesting slide. We are releasing every 6 months right now a new version of TeraFlow. We are trying to push for having new releases, as said, every 6 months. And the idea is that this TeraFlow project, TeraFlowSDN project, started as an European research project at the very beginning. That means it was just one single research consortium under the umbrella of the European community that was developing the first versions of TeraFlow. After this project finished and during its execution, we were migrating to ETSI because we were thinking, okay, the thing we are developing makes sense. It's something that we really think should be developed and should last. So we decided to move to ETSI. And within ETSI, then other European research projects decided also to join and participate. Right now, we have, you see, a number of research projects. It's on the right-hand side. And on the left-hand side, we have a lot of standard and SDO entities. We are serving somehow as a place for linking both the standards and the research. Okay? And well, something that I haven't said, but almost 1 month ago, we were releasing the last version of TeraFlow, TeraFlow Release 3. So now it's stable and it's available, so you can use it. About the architecture for this new release. You will see, well, maybe in this screen you cannot see it easily, but maybe let me choose the pointer. So most of the components are being kept by now. We have plans for evolving some of them. I will not spend time on this because this is more for technical sessions. But the thing that I want to highlight is that some new components arise. Okay, so we have now a forecaster component that lets us forecast, for instance, the capacity of some links. And for entire topologies, this is especially useful when you need to provision new connections with some schedule, because that way we can say, okay, for this new connection, I want to envision which is the forecast of traffic consumption in my network and be sure that my service will have enough resources in the future. Okay, that's the idea. For the end-to-end orchestrator, this component is about provisioning multi-layer services. That means services that involve both the IP layer and also the optical layer mainly. This is the main focus. It's a very new component, so right now functionality is quite limited, but we are pushing in some of the research projects that I was mentioning to make it grow. Same happens for the new optical controller component. This is mainly for controlling optical networks. In the past, the only thing that was doable with TeraFlow for optical networks was essentially to offload the management of the optical network into a specialized optical controller, for instance, through the ONF Transport API interface. Right now, TeraFlow has support for managing the ROADM devices, the transceivers and transponders and so on by itself. Again, this is a newcomer to the TeraFlow microservice ecosystem, so the functionality is still in an initial stage, but we are pushing to increase the capacities and the functionalities this component offers. And last but not least, the BGP-LS speaker. I will not invest time on this component because my colleagues from Telefonica will be presenting the functionalities of this component in deep detail in the following speech. So I will let them the presentation of this functionality. About interfaces supported. Well, I don't want to spend a lot of time here. The thing that I want to highlight is that we have a set of NBI and SBI interfaces in TeraFlow that can be used for letting upper layer systems to connect to TeraFlow and request different kinds of services, interrogate topologies, also to manage transport network slices and so on and so forth. And also on the SBI, we have a number and a growing set of drivers that we can use to manage underlaying network devices and underlaying intermediate controllers. So, well, if you have interest in any of them, let me know, and at some point I can explain you, because explaining all of them, it can take quite a lot of time. So feel free to ask me, or through Slack if at some point you have the question. And about demonstrations and use cases, well, I will not explain each of them one by one, because, again, will take a lot of time. Things that I want to highlight is that we have integration with ETSI open source manual from the very first version of TeraFlow, and that's something that is very good, because we are using also this in order to integrate inside the ETSI laboratories an automated test that will validate that open source manual with the management of the networks by means of TeraFlow works properly, and we will integrate these in the CI/CD pipelines of these two software projects. So in a way that we ensure that in the future versions, everything is managed properly between them, and hopefully other projects will be incorporated in this automated testing, so that way we ensure that the ecosystem of projects under the ETSI umbrella are properly integrated between them in the future. We managed to demonstrate a number of well, experiments and use cases based on anomaly detections, using machine learning, transport network slices with SLAs, slice grouping stuff, hierarchy of SDN controllers. For instance, here we can have TeraFlow being deployed as a parent SDN controller, and then having TeraFlow also as child SDN controller, and the childs were in charge of managing specific domains and technologies like IP or optical, and then on top you have the parent that manages the end-to-end connections. So many experiments. Also, we were playing with distributed ledger technologies for inter-domain use cases. optical SDN controllers, and the very last one that will be presented in a couple of weeks is what we name as the data plane in a box with Container Lab. So the idea is that we will offer a virtual machine that will have TeraFlow installed inside with a network emulation software named as Container Lab. And in this network emulation software, you will have a number of emulated routers, real routers, I mean using real network operating system from different vendors, and you will be able to manage them with TeraFlow. So the idea is that this is something that we were asked in the past, that whenever we want to play with TeraFlow, we are missing some box that we can just start in our computer and play with and see how it works. And well, the idea is that this will start mainly with routers based on OpenConfig, but I presume our colleagues from UBTech at some point will incorporate support maybe for P4 and so on, so we can keep growing this use case, and this could be something very nice for the community to be able to play with TeraFlow in the future. And well, just describe some of them, just to be fast and not borrow so much time. In case you are interested in something related to TeraFlow, we have a single entry point. It's the tfs.etsi.org. Over there, you can find whatever resource you want related to the TeraFlow, including the leadership groups, the technical steering committee group members, some of the important dates that well, we are presenting TeraFlow or some event related to TeraFlow. So over there, for instance, the most important ones right now are in a couple of weeks at the EUCNC. We'll have a special session that will be led by Sylvia and Ricard. Over there, we will be presenting the bridging between research and standardization in terms of open source. So if you have the chance to attend, you are very welcome, and we will be happy to see you there. Besides that, we are having the kickoff of the TeraFlow SDG in mid-June. Again, it will be online, so if you have the chance to join, you will be very welcome. And for and by mid-November, we have the ETSI conference and Hackfest over there. If I'm not wrong, Sylvia will correct me, or if you want to present this, feel free. But up to my knowledge, the idea is that the different SDGs will join there, and we will have a joint session between all of us. So if you want to join, you still have seats available for coming. Again, we'll be happy to see you there. And nothing else on my side. Just a question. Are you ready to start? If yes, let's go ahead. Time for our Telefonica colleagues to jump in. Thank you.